Good afternoon, my name is Tevik, and this is for Calculus 3 with Professor Seeberger. This is our discussion 10 video post. So I was originally going to do problem number 1 from homework 13, number 3, but since it got graded, I'll be changing the question up a little bit. So today we're going to go over Taylor Polynomials in first and second degree. So our function is f of xy sine x sine y. I decided to use sine x and sine y because it's not varying too much from the original problem, so it should still be easier to follow. So we'll be doing it for x and y near our point 0 and pi over 2. Our first step is to find the partials with respect to x and y. Then we do the second partials with respect to xx, yy, and xy. So f of x, xy will be cosine of x, sine of y. Our first partial with respect to y excuse me, is sine x cosine y. fxx xy will be negative sine x sine y. And continuing on, so once we have those, we will plug in our point 0 and pi over 2 into the original function and then all of our partials. So f of 0 pi over 2 will be sine of 0 sine of pi over 2, which equals 0. Now plugging in for all of our partials, sorry, those should be pi over 2. That will give us cosine of 0 sine of pi over 2, which will be 1, sine of 0 cosine of pi over 2, which is equal to 0, negative sine 0 sine pi over 2, 0, negative sine 0 sine pi over 2, 0, and cosine of 0 cosine of pi over 2 equals 0. Now the reason why most of these are 0 is because sine of 0 is 0 and cosine of pi over 2 is also 0 because of the unit circle. And now our first degree our original equation is L of xy equals f of xy plus f of x xy times x minus x1 plus f of y xy is y minus y1, where x1 and y1 are these points right up here. So plugging everything in, our first degree, our f of 0 pi over 2 is 0. Our f of xy times x minus 1 will be 1 times x minus 0. And then our f of yxy times y minus y1 will be 0 times y minus pi over 2, which equals x. And this will be our first degree. Our second is the equation q xy equals our first degree Taylor polynomial plus our second partial xx xy divided by 2 times x minus x1 squared plus f of xy times x minus 1, or x minus x1, excuse me, and y minus y1 plus our second partial with y times y minus y1 squared. And then plugging everything in, since we already did the first partials and the second partials, will be x, because that was our first degree, plus 0 over 2 times x minus 0 squared plus 0 times x minus 0, y minus pi over 2 plus 0 times y minus pi over 2 squared, which equals x again. And that's it. As long as you keep everything organized and in order, plugging it into the first and second degree Taylor polynomials should be straightforward. Hope this helped. Thank you.